Thanks, everybody. Thanks for coming to our wonderful global headquarters. We are sort of bursting at the seams here. Just going to give you a quick update. I think a lot of you have not heard much about the company. I know Steve has, but maybe John. For everybody else, I'm going to try and go through everything soup to nuts and acquaint you with our technology. For the most part, we've had a few interesting new developments over the last 3 to 6 months or so that we have been telling the market about, and so I'm going to cover those in particular now. But feel free to ask questions. I know you always will. None of you guys have been known to be shy. Actually, I'm going to run this myself. So what do we do? ClearSky delivers on-demand primary storage with integrated offsite backup and disaster recovery business continuity features, all as a single service, single endpoint. What we provide enterprises essentially is the ability to just pay for their data once and then access it across multiple locations, both private cloud and public cloud. With that single durable copy. So there's a very, very significant TCO savings as a result of that. A little bit of a backgrounder on the company. We were founded in 2014. We've always been here in Downtown Crossing, and we are now about 45 employees. This number actually changes in real time. We are about $39 million into the venture capital pool. Our lead investors were General Catalyst and Highland Capital, both Boston area firms, and we also have a Series B round that we added Polaris Partners and a small strategic investment from Akamai. And when you see what we do, you'll quickly understand why Akamai might find this interesting. The company was founded by myself and Ellen Rubin. Both of us are from the enterprise world. Ellen was previously at CloudSwitch as a co-founder and also led marketing at Netezza. I was at Dell EqualLogic for 5 years, and I got in there as a result of being the software leadership at EqualLogic from the very beginning. So a long time in storage. Some things we've been out in the market for a little while now. One of the customers, the biggest customer that we've made public so far is Partners Healthcare, which is, I guess, I didn't know this, it's the largest employer in Massachusetts at this point, so it's actually a fairly large account. We target Fortune 1000 enterprises with large data management needs. We generally are providing them a service to help transform the way they build and manage data infrastructure. We just announced some expanded capabilities, specifically around data protection, this has been the most recent news that came from ClearSky. We are leveraging the back end, which is public cloud back end of our system, to provide a complete offsite backup of customers' data and really kind of extend the value prop around our data durability story. So not only do customers pay for that single fully protected copy of their data, but they're able to eliminate a lot of duplicate infrastructure and management costs. Backup is generally done by making tons and tons of copies, so we eliminate that. We reduce the overhead from that, including the licenses that most of these guys have to buy. We reduce all the secondary infrastructure for business continuity as well. Much fewer networks and lower bandwidth needed. We have a very low RPO and RTO, which is very, very difficult to build out in piecemeal fashion across all the enterprises that we talk to. And our TCO reduction is in excess of 50% when you take it into account all of the things that we eliminate. So it's been well received by our customers in the market. What our customers typically do, they use us for primary and secondary storage in a number of different use cases, analytics and machine data, really large footprints with respect to data size. We have a really interesting value proposition because our architectures, as you'll see, is backed by the public cloud, so we don't run out of space. You don't have to pre-position huge amounts of capacity to service these workloads. Production VMware, the backup infrastructure, test and dev, and a lot of the other secondary use cases are part of the set of things that our customers are actually buying us for. In particular, DR and workload mobility, and I'll get into some of these things. What we generally sell into is a world that looks like this. So all of you that are storage experts probably have seen this before. In general, customers of the size and shape that we sell to have this kind of a problem where they have primary infrastructure with primary storage and then some secondary storage on site. They have some form of on-site backup for the primary and secondary storage. And then they also have an offsite backup. They have business continuity needs, so they also have another set of primary and secondary storage in a secondary site. They have all the networks to hook all this stuff together. And then they're off making copies. So you can easily end up making 5, 6, 7, 8, 9, 10 copies of your data. There's a lot of networking and a lot of copying that has to happen. And also, keep in mind that you have to actually have to keep all sorts of metadata about what point in time are all these copies. So it's a very complicated mess. We say that there's a better way from our perspective. Leveraging a cloud-based solution allows you to keep a single durable copy where you have the master essentially for all your data in a single durable location that's off-site, that's secure. And then you can just pay to access your data from our access points, which you have in your multiple data centers or possibly in the cloud. So this is a huge simplification in terms of the overall infrastructure footprint that a customer has. Most of the capacity is sitting behind the wire, so to speak, and so they don't have to manage it. It's managed by us. The net of what we've built here is a new storage architecture, which is really essentially hybrid data access. Data backed by the public cloud or any large private cloud infrastructure, but accessible everywhere, where customers get on-demand economics, which is what you really want the cloud for, a single durable copy instead of having multiple durable copies, the security that's required in the enterprise, built-in data protection, so you don't actually have to build all additional infrastructure in order to get the protection that you need, and most importantly, the ability to access it anywhere in this hybrid world where you have public clouds, managed clouds, all sorts of other different data centers and data sharing that you need to implement across all these locations. How does it look to the customer? We basically run what we call a metro-based service. It's run out of points of presence in various urban locations, so hence the similarity to something like Akamai. We provide sort of the end-to-end of the storage lifecycle in terms of the services that we provide, both primary, secondary storage, including backup, and also the disaster recovery capabilities and orchestration that you need. So that is end-to-end. And to the customer, we're an SLA. So we provide a much tighter SLA than a cloud provider would. So most of the cloud providers, even the big public cloud providers, are providing 3 nines SLAs. Well, actually, I don't know if they are 3 nines anymore. After the 5-hour S3 outage, I think to get to like 5 nines, they'd have to be up for like 50 years now. But 3 nines is probably about what they're able to provide. We actually have built a system that's 5 nines, and I can get into some of the details of that in the coming slides. Our architecture, from a customer perspective, is really an edge-based architecture. A customer gets an edge cache from us. It's a highly available appliance, basically what you'd expect from a storage array chassis in terms of all of the hardware components, including dual controllers, dual power supplies. We connect it into our cloud or into our network with 2 lines as well. So pretty much everything is redundant. The customer gets either a fiber channel or iSCSI endpoint. And it essentially takes the place of their SAN. So they get all of the capabilities that they would expect from a regular SAN appliance, including the VMware integration, and we'll talk about some of the vCenter integration that we've implemented specifically for backup and restore in a little while. But this is essentially a 2U appliance that's all flash, that's present in your data center, that represents all of the hot data that is being used in your data center. And this appliance can actually scale out. So we can, you can both scale it up, we can add a lot more flash to it, and then we can scale it out. So we can have a number of appliances if really needed. So we can get up to greater than 100 terabytes of hot data, which is, would be all flash. If you do the hot versus cold math, that's an immense amount of data. Behind this appliance is petabytes of data and the scalability and the scale and immensity of the cloud. And so you never really run out of space. So you have a very, very small, compact footprint in your data center. As you're using the service, your data is ingested into our back-end systems, and as a result, once it's behind the wire, if you have a secondary data center, it's actually just a matter of plugging in another appliance in a second data center, and you get access to that data. You do not have to stand up an entire copy of hundreds of terabytes of data in the second data center and then make copies. You just simply plug in. And you get access to it. So this is a very, very interesting way to get disaster recovery because you don't have to pay for the data twice. Essentially, you only pay for, it's roughly the price of a storage array, and you're getting this disaster recovery capability for free. One of the...
So wait, on the pricing, I mean, you say it's roughly the price of a storage array. Those things range from QNAP to VMAX all-flash array.
We are roughly the price of, we've actually done specifically, our pricing compares to what you would pay for, the mid-range Nimbles.
Okay.
NetApp. Actually, we're cheaper than a typical NetApp.
I don't expect you to give me per terabyte pricing, but kind of getting to the range is...
Yeah, it's a mid-range price. So if you look at it on a dollars per gig basis, you're roughly paying about what you'd pay for a mid-range storage array. On the other hand, you're getting access from two locations, which would mean that you'd have to buy two of those mid-range storage arrays in order to get what you were getting here.
Okay.
The other interesting capability is that you can plug in the cloud. And so one of the things that we've built recently is the ability to take a software version of that edge and run it inside of Amazon. So because we're already connected into Amazon and the backing cloud is S3, one of the capabilities that we're providing is for our customers to bring up compute inside Amazon as EC2 instances and essentially have an on-demand data center. We already have a customer in the Mid-Atlantic region that is going to be using this as a DR data center. So another really, really interesting cost-effective use case is to just not have a DR site and just bring it up when you need it. And a lot of interest in that area, and obviously you can think about some of the developments around Amazon and VMware going forward that we might be able to exploit there. If you go down a layer, what makes this all possible is our infrastructure inside that network. So we're not the internet. In fact, everything is done over private lines. When you connect into our network, you do it over EPLs. So, for example, here in Boston, we have a very, very dense and rich, fiber network that is run by all sorts of telcos, and so we're able to get very, very cheap connectivity to our customers' data centers. And we operate this network in a redundant fashion. Every customer gets 2 private lines at a gig each. Going into every site. We're able to do that because we have very, very highly connected buildings, and so we have a lot of options with respect to the connectivity marketplace. We set up points of presence in a number of cities, and we'll continue to expand our footprint. The idea is that our customers have to be within a millisecond or 2 of where our point of presence is. So what we're trying to do is correct for the speed of light. If you were to reach into the public cloud from Boston, your best case scenario is something like a 50 millisecond round trip time between the access and the response. And so in the end, that's very, very unacceptable for storage. What we provide is very, very low latency connectivity and also a lot of caching inside of that network, so you never actually have to deal with that. Typically, customers in the Boston area, for example, are sub 1 millisecond to our POP. So anyone who's within the 495 belt is microseconds away. And so hence we're able to provide a completely primary storage-like experience without the entire footprint actually being on-prem. Additionally, the way the system works, when data is ingested, it's actually acknowledged in the POP. So you're synchronous to the POP across the entire metro. This is essentially how we get RPO 0. So all your rights are acknowledged immediately in the POP and then acknowledged back. And so what that means is that if you were to lose a data center, you have RPO 0 at the other data center for whatever storage was connected to the primary.
Assuming they both connect to the same POP.
Yes,
right?
that's right.
Okay.
Yeah, we do have that. So inside of a metro is the caveat. It's RPO 0. So this is specifically what I mean when I say we can offer RPO 0. The whole point of this architecture is that wherever we are, you'll have a POP and you'll be within a couple of milliseconds. And so as we operate this infrastructure, we obviously, in order to implement our cloud edge, we have to have a POP nearby as well. So we are in Ashburn, Virginia, for example, inside the Equinix facility there, and we're able to provide really low latency storage services for customers that have the cloud edge inside of EC2 as well.
Who pays for the connections, the fiber connections to the POP? Is that the customer, or is it part of the service?
It's all part of the service, actually. So I should point that out. One throat to choke, one price, one bill, and the bill is denominated specifically in dollars per gig per month.
So it's all rolled in together.
Yes,
what's the minimum contract length that you require?
It's length or size? So it's size is.
Yes.
We start at 20 terabytes, so we want a 20 terabyte commit to buy in. And that's, obviously we have a lot of fixed infrastructure that we have to deal with, so 20 terabyte will actually cover it. And then from there, it's essentially pay as you go. Once you're in the buy-in, it's up to you to work out how much minimum buy-in you want. So obviously the more you guarantee us, the lower we'll bring down your price.
And is it a 1 year, 3 year commitment?
We'll do 1 year to 3 year. Our typical deal these days seems to be 2 years. Given the dynamics of the market, no one really wants to lock in for 3. Yeah, it's and a lot of what happens in the storage market, especially in the cloud storage market, is that every 18 months you have these precipitous price drops, which do get reflected in how we sell. So there's always a chance to re-up, and you kind of want to do that in the cloud model. Other interesting thing that everyone asks about is security. So in this arrangement, we took security into account. We're actually, if any of you have ever gone through a SOC 2 audit, my sympathies are with you. We're in the middle of one right now. It's a miracle you're all allowed to go into this building. So we have a SOC 2 audit underway. We built a system end-to-end to be completely secure. The edge caches are there really in the customer prem because we wanted the encryption keys to be living on-prem with the customers, or at least in the customer's control. We wanted to be out of the key management business to the extent that was possible. So the keys are here on the edge at the customers. Each customer essentially generates their own key. And we have TPM technology in the edge caches. These are essentially Intel motherboards, so you can put TPMs on all of them. We use the TPMs to manage the keys. We encrypt all the data at rest on self-encrypting SSDs. We encrypt data the minute we ingest it, so that when we send it into the network, it's encrypted. The connectivity between the edge and the POP, even though it's a private line, we still run TLS. So there's a bidirectional key exchange. There's TPMs on the hardware inside of the POP as well, and so they mutually identify one another, make sure everything's okay. So we've done a lot of work to prevent some really bizarre things from happening. So we had some people that came in and asked us what happens if someone steals the edge cache and tries to connect it in their own data center. So the answer is you can't do that. With TPM, we'd actually figure out that who you are, where you were stolen from, and where you're supposed to be talking to us from, and then we'd kick you out. So things like that have all been accounted for. Pretty much all of each customer's data is in its own encryption domain, and then each customer gets their own space inside of the cloud. It's well segregated. We don't over provision the network, so everyone pretty much has enough network piping to run full blast to the extent that that's possible. And we actually plan out the network in such a way so that the network is not a bottleneck. This is never on the public internet. The only place where there's any presence on the public internet is the management console. So if we have time, for a demo of that, that's actually accessible from a cloud user interface. It runs in Amazon AWS. That's the only place where we have an exposure to the internet, and that authentication is actually multi-factor. So you can't just log in with a username and password. You have to get an email and then acknowledge that you received an email by giving us a token. So it's always multi-factor across the internet. So pretty much everything here is a private network. These lines are private lines going down to Amazon today. Any cloud that we support in the future is going to be private connectivity as well. So we're essentially managing very, very high bandwidth connectivity into the individual cloud providers so that we can not only have better security, but also better latency. For example, from our POP to Amazon East is roughly 11 milliseconds in latency from here. So that's actually pretty good compared to the 50 to 100 that you'll see in various locations around the city.
What do you attribute that to?
The peering. Well, in the internet case, or
No, I mean, just,
in ours?
It seems like there's a. So you're saying normally there's a 50 millisecond, but for somehow you guys magically get 11. What do you attribute that to?
It's a private line, so we never. Yeah, we don't peer with. So in the case of the internet, it's really set up as a bunch of peering points between internet service providers. Every time you hit a peering point, you get traffic copped. And the latency just piles up. So you traverse a couple of service providers, and then you have this ballooning latency problem. You also have a lot of people downloading Netflix and things like that as well on those peering points. So it's not going to help you very much, especially if you're trying to use it the wrong time. The other thing that's really interesting about us is that as a workload, we're the opposite of the way the internet works. Usually in the internet, you have an origin somewhere out in the cloud somewhere, and you get content streamed down to you. We optimize for the opposite direction, and that's evident in a lot of the use cases, like for machine data, for example, where you have, machines will just generate data. They won't stop because there's traffic. They're just going to keep going. You have to be able to ingest. So this is a bidirectional network as well. So by keeping out of the internet, it allows us to actually build it out the way we want. So what do we deliver? So we allow our customers to pay as they consume. So they can scale up or scale down. We do have customers that have their bills go up and down based on what they actually have used over the course of the month. We have both primary, backup, and DR in one service. So once you set up the parameters, including the physical topology of our implementation, you get all of this pretty much with one bill. No replication, so you don't have to worry about all of the problems inherent in having multi-site replication, and also none of the license fees and complexities. So integrated recovery. So our snapshotting capability is super fast and can be super deep. So you can have thousands and thousands of recovery points. We're not like a conventional box storage array where you run out of space to keep all these records. Every time, even our metadata gets folded out into the cloud, and so we can just go on forever. Data eventually just gets cold and doesn't get accessed anymore, but that doesn't mean that you can't access it if you really needed to. We have low latency access to it wherever it happens to be sitting.
For your DR piece, what orchestration engine are you using to like start up the VMs and whatnot, or is it just a manual process?
It's so we built our own tool.
Okay.
This is sort of like early in our in our functional lives. So we started out by building out our own tool. We probably will start doing integrations with third-party tools as well, where that's appropriate or even possible. So VMware has a tool, obviously, with SRM. But we expect to try to integrate wherever it's easy. But lowest common denominator, we're going to be able to do on our own console, and we're going to continue to expand that. So get full redundancy while only paying for that one copy. So the cloud providers that we use are multiple copies. The S3 durability statement is 11 nines, so that's order of 5 copies or so. We are able to provide 5 nines envelope around that because of the infrastructure that we put in place. And we have our certified security and encryption policies, which allow us to carry some sensitive data. In fact, Partners Healthcare is a healthcare provider, and I can't think of anything more sensitive than that except maybe your credit card data. We're working on that. So let's talk about some of the most recent developments. Back to backup and DR. I mentioned the RPO 0. Inside of a metro area, you do have RPO 0. For the most part, you're 15 minutes or less for the point-in-time snapshots, and less is pretty much a function of how inclusive your snapshots are, because we're trying to do things across large numbers of consistency sets and so on. So it really depends, but it's possible to go lower than that. Once you connect a snapshot, your RTO, once data is requested, is sub 1 minute. So even if the data is cold, we're able to bring it back into the caches very quickly across a very, very large, low latency network. RTO is great. And we have 2 UIs. So we have the VMware one, and we also have our own web-based UI that orchestrates these things. For the VMware environment, we actually do this in data store context. So we also have a catalog, and we're going to have a demo in a minute where Darren will show you how all this stuff works. But we have a catalog of all your VMs and when they were snapshotted, so you can actually go and search it and decide what VM and from what point in time you want to recover from. And we can expose that to your VMware cluster so you can do a recovery. Fully integrated in vCenter. So I think this is time for the demo.